Paul Vixie is one of the history. Let's say he's one of the Internet Hall of Fame's nominees. 2014, he developed the DNS. He developed secure DNS and many other things like maps. Like now he's a vice president for security at Amazon IFVS. And I'm very glad that we can have him here in this conference, because this is a conference exactly suited on what he develops. Okay, your turn. Yeah.
I certainly glad to be with you. I wish I could be there in person. I've had extensive business travel for work, and so it was simply not possible for me to get to be where you are. So again, I thank you for this invitation. I wish I could be there in person.
You are welcome.
Perhaps next year. I want to talk today about some changes which are coming to the internet, and they are somewhat inevitable because the team who works on these things are volunteers. And it is the consensus among those volunteers as to how they move forward. And we were not there. And that means that the outcome that we're going to get will not necessarily be best for security and resiliency of the internet itself. So I'll speak first about the nature of modern site security. By site, I really mean a edge network that connects to the internet, but it also has some local devices. So this might be a family's home or a corporate network belonging to some commercial entity or perhaps government agency. The internet is a network of networks. We all create those networks and then connect them to the internet. So every edge network contributes some part of the total internet. And every edge network in this terminology is a site. It is a place where things happen. And the security of those sites has dwindled. It's really quite rare now to encounter an edge network, privately operated, secure edge network that is actually secure. And to the extent that it will be secure, it is heuristic security. We try to look at the actions, the packets of each host connected to our network, and then from those patterns, we discern whether that host is acting according to policy. And that's a very weak mechanism. But, if you don't have the source code, if you did not build the device yourself, there's no other way to know what a device is doing except to look at its packets. This is hard. It's just hard because you don't know if that IoT device or even your smartphone or your laptop is making the network traffic that you see. Maybe it's something you asked it to do. Maybe it's something that it does to phone home and to tell its maker what to do. But you don't know other than by looking at that traffic. And, so just looking at the traffic is a weak system. It's not what we would have chosen. It is, however, what little we have. I'm concerned about having less. It's important to remember the reasons why site security is so limited has to do with growth. When the complexity of your system increases, but your understanding of that system does not increase with it, then you're at a growing disadvantage. And it'll turn out from a internet security point of view that the attackers will understand your network better than you do. They'll understand the devices on your network better than you do. And by complexity, I'm not limiting it to hardware, although certainly hardware does get better every year. It's called Moore's Law, and we get more transistors per chip, more memory, maybe a faster cycle time. We get the same performance from something smaller. You have more lines of code, more programmers having participated in creating those lines of code. The code is in need to be patched, but increasingly it does not get patched. In many cases, the maker of the hardware will have gone out of business. There is no way to get a patch, even though there is a known vulnerability. That's the kind of thing I mean by the gradual increase in complexity. Yeah, and there is a philosophy which has come into its own here, where a corporate network assumes that a breach has occurred. They assume, in other words, that on their network right now, there are devices which have been taken over. The control of some of their devices is in the hands of bad actors. We would call this a botnet, and they are so prevalent that many sites assume that there's a botnet, maybe more than one botnet, operating from within their network. This sounds terrible, but it is realistic. This sort of thing would lead you to no longer trust the devices closest to you on your own network, and to make sure that they're not in a position to eavesdrop. This is terrible, but it's all we have. And let me remind everyone that in this type of a Cold War between those of us who defend and those of them who attack, the advantage always lies with the attacker. They can study our defenses at their leisure. And when they win, they profit. Now, we do not have the leisure of studying our devices. In other words, we're here to do something else. We want to use the network to do something important. And so the study of the network is not our primary goal. We don't work on it all the time. And when we win, we do not profit. Our benefit if we win is that we do not lose. But we don't know, had we lost, how much we would lose. The attacker knows, if they win, how much they won. So there's a structural deficiency in the way we've built the internet that has led us to this position where we are at a perpetual disadvantage. So we're in a point in time, and that point in time had some road marks. Specifically in 2013, a large change was input. And what happened was a government contractor, a single person, had some kind of a crisis of faith, and put a great many US government files onto a thumb drive or a series of thumb drives, and walked out of the secure government facility with those thumb drives, and then flew to Hong Kong, where he disclosed the contents. And it was a big event. This was the biggest headline in our field that year. And in fact, many of the things which he was able to disclose were quite disturbing to many in terms of the common practices of the National Security Agency in terms of eavesdropping on its citizens or committing various, espionage actions against non-hostile parties. A lot of people in the world were shocked by this, because if you don't know how history has progressed, you don't know how we got here, you don't know how the world works. If you're suddenly told this is how the world works, it can seem like quite a shock. But, for me, at least, I assumed that something like this was going on, because that's what governments do. The people who are doing it are patriots trying to defend national security for, in this case, the United States of America, but also for all of the allies, all of the friendly nations, all of the trading relationships around the world were also part of that which was to be protected. And it's certainly it's hard to hear how this is done. It feels like dirty tricks, but this is how nations operate. In the history of the world, nations that don't operate this way don't last long. Anyway, those who were panicked went to the Internet Engineering Task Force and said, we can't live this way. This is a terrible thing, and we must use the internet to change it. And so one of the immediate outcomes was RFC 7258. The RFC series is like a Bible for internet engineers. It's telling you what to build and how to build it. And in this case, what they were told was encrypt everything. Assume breach. Do not transmit clear text signal, because it will be seen by nation-state actors and potentially also commercial actors who do not necessarily have your company's safety as their first concern. Title of the document was Pervasive Monitoring is an Attack. And, we must give credit to the truth. That is the truth. It is an uncomfortable truth that we live with. Some years later, they added to their Bible another RFC 8890, wherein they decided that the internet is for end users, because it seemed that it had become unclear why do we build this thing and who are the beneficiaries? Do we build it for the nation-state security apparatus? No, we don't. We build this for ourselves. There are some naive problems with this model. And I say naive because the writers of these RFC documents are absolutely passionate about personal freedom and autonomy. They are on the side of humanity itself. They are trying to undo the state of affairs which Edward Snowden showed to them. They are trying to get us to a place where end users are the prime movers of the internet. So an example of the naivete of these passionate defenders of freedom is that there was no carve-out, no exception made for site security. And in the case of site security, you must be able to do pervasive monitoring. You must know what the devices on your secure private edge network are doing. You have to be able to look at the traffic. And that's not a good security model. It's just all we have left, because we don't have the source code to all those devices, as we might have in the pre-commercial era of the internet. And they made no distinction about what kind of end users they meant. And, so it's not clear if they mean that the internet is also for intruders or malicious insiders or botnet operators or the poisoners of supply chains. There are a lot of end users who might wish to use my network, and therefore it's to their benefit that we say that the internet is for them. But it isn't. I build my own corporate network. I build my own home network. It is not for the end users. It is for me, the builder. And part of my job is to protect the end users against poisoned supply chains. And so if you build a network that I, as an edge network operator, or any of you as edge network operators, have no visibility into, you may have made the situation worse for the population you're trying to protect. They also made no distinction for surveillance capitalism. In other words, some parts of your supply chain, your smartphone, your laptop, whatever, might be in the service of its maker more so than in the service of you. And so you might need to be able to see the traffic so that you can audit the security assurances that were made to you by your smartphone, or the maker of your smartphone, or the maker of your laptop, the maker of your set-top box if you watch TV. So this was done, and it was done in ignorance of other facts, and that's going to have some impact. So if you're going to defend this stuff, you're going to be breaking some rules. There are rules in the Internet Protocol Suite that specify, for example, that data transfer is end-to-end, and that middle boxes shall not tamper. We break that rule every time we install a firewall. And it's necessary to break that rule, right? So that rule is itself somewhat naive. If the internet is still a network of networks rather than a network of end users, including intruders, then we're going to break whatever rules it takes to fulfill our security mandate toward our family, toward our customers, toward our employees. And what's happening when you encrypt everything is that very necessary thing becomes harder, if not impossible. So let me mention in passing the first protocol which implemented these new philosophies was described in RFC 8484, which is about doing DNS over the HTTPS protocol. HTTPS is the web protocol. It is the thing that our web browsers use to fetch almost all of the content that we see. It is a ubiquitous, universal protocol. It's used for almost everything. And it was chosen as the bearer for DNS because of its ubiquity. And that's because DNS is a very frequent target for surveillance. If you can see DNS, then that will help you to characterize the rest of the encrypted traffic that follows DNS. So it's a really interesting target for attackers, whether they be intruders, surveillance capitalists, or nation states. Everybody wants to know what the DNS signal contains. And so on the first page of that RFC, they say that a use case for this protocol, the reason it exists, is to prevent on-path devices from interfering in DNS operations. Okay, that's very clear. What's not clear is that my firewall is on-path. It is an on-path device. And I intend to interfere because it's my network, it's my devices, it's my family or my employees. So I have both a right and a responsibility to do that which this protocol intends to prohibit. Later, RFC 9000 and a series about maybe half dozen RFC documents, they've advanced beyond DNS over HTTPS, and they pretty much want to replace the TCP/IP protocol, which is what we use for everything, including HTTPS, email over SMTP, secure shell over SSH. It all uses TCP. And so now they are replacing TCP with a more secure protocol that is secure by default, as opposed to TCP, which is clear text by default, and you have to decide that you're going to encrypt. With the QUIC protocol, you don't get to decide whether to encrypt. It only works when it's encrypted. And in terms of manageability, there's a document which claims that the QUIC wire image is not specifically designed to be distinguishable from other UDP traffic. UDP is the peer protocol of TCP. It is the user-defined payload or user-defined protocol, and it is much more lightweight than TCP. It's not reliable. You have to, explicitly acknowledge UDP, usually by answering a question. DNS traditionally works over UDP. NFS, NTP, all of these things work over UDP. If you've ever tried to boot up a router using the TFTP protocol, that was UDP. And so what they're saying here is that QUIC is kind of mixed in with your other UDP traffic. And it's actually not true, what's written here. I mean, it's true as far as it goes, but it's misleading, because the QUIC wire image was specifically designed to be indistinguishable from other UDP traffic. And I argued that the document ought to say that, but I did not achieve consensus. In any case, this traffic will appear on your networks, has already appeared on your networks, because early versions of it are already present in the Chrome browser. And they're already spoken by various web servers, including those at Google. So this is already happening, but it is not yet a universal recommendation that all devices speak this protocol. That recommendation is forthcoming. You should think about what this means. Now, this would not be as big a problem without a corresponding change being made to the TLS protocol. TLS is the transport layer security. It is the security that we use on the web. This is ubiquitous. It is universal. And the version that we use now is version 1.2 of the TLS protocol. But TLS 1.3 has been standardized and will shortly be recommended. In TLS 1.3, there is a change to part of the signaling. In particular, the server name indicator, which in TLS 1.2 is in the clear, can be seen by a non-path actor, firewall, for example. In TLS 1.3, this information will not be in clear text, and it will be possible for TLS protocols to work perfectly well, but to not expose to your firewall what is the intended target, what is the web server name that we're trying to reach here. And so those of us with so-called next generation firewalls can no longer have a policy of permitting the visitation of some websites by our family or our customers and forbidding others. That policy becomes unenforceable once the traffic becomes undetectable. This was a goal. This is not an accident. Our firewalls are seen as equivalent to the real problem, and thus no provisions have been made or can be made to let those firewalls have the visibility that they wish to deny to nation-state actors and ISPs. We are like a baby being thrown out with the bathwater. We don't have good choices. And if you're in a position where through no deliberate action of your own, you have no good choices, you feel that you must do something, but there is nothing that you can do which appeals to you, that usually means that you are in a fight, that somebody has chosen to have a fight with you. And one of the powers that they have, this happens in all combat, all conflict, is that your operating conditions will be changed by your attacker. And the alternatives that you have, the defenses, in other words, that you might employ, have also been managed for you by your attacker. So as our traffic goes dark and we can no longer see what our own networks are doing, then we're going to have to do something about this. Some sites, many, maybe most of the edge network will do nothing because they can't invest as necessary to try to keep control of their operating conditions. And so for those, they just have to learn what are the new rules, and especially what are the new incapacities. There may have been a time that a corporate network operator could be told by some outsider, hey, you're DDoSing me, you're spamming me, you're sending me traffic that I don't want, please stop. And it used to be that you could look at your edge network device and figure out, well, where is that traffic coming from? And you'll find that perhaps some electronic toaster in your kitchen has been taken over by bad people, and it's part of a botnet, and all you have to do is unplug the toaster and you can stop the attack. Well, now you can't. Now, if somebody complains to you that you're spamming them or DDoSing them or what have you, what you'll be able to do in this new world era is to say, I have no knowledge of what my network is doing. I cannot take responsibility for the emissions of my network. I feel sad that you're being DDoSed, but there's nothing I can do. That is the new world. Others will make changes. And if they can afford to make changes, they'll be expensive changes. Right? These are not things that, oh yeah, we should have done that anyway. No, these are things which will cost in other ways, but will prevent this change from occurring. So if this change is an existential risk to your family, to your company, to your government agency, to the, in other words, the operators and users of a secure private edge network, you might make a change that is going to be hard. If you install an application layer gateway, like a proxy, and then you insist that every device on your network please use that proxy when they want to exit the network, that's not uncommon for proxy settings to be managed by the enterprise. It's impossible to get this done for a family. And I must note that there is no configuration by which IoT, that electric toaster, for example, can be told the proxy to use. They all assume that they have end-to-end rights. And so if you move to this model where you have a proxy that must be used, you will be limiting the kinds of devices that can use your network. That is going to be an expense. You could also do what I do, simply block UDP by default and only permit it if it's coming from known DNS servers. So DNS needs UDP, but only your local DNS server needs to speak UDP through the firewall. So if you know where your DNS traffic will come from, you could simply deny all UDP, except that which you know to be DNS. This is not as expensive, although it means, as an example, that the Chromecast device from Google will no longer work because Google does not believe that it can trust your local name server. It always uses 8.8.8.8. And if you block UDP, you're gonna have to change from your Chromecast to some other set-top box device. Apple is a good choice. The Amazon Fire Stick is what I use. But you must be prepared to sort of evaluate the cost of this on a device-by-device basis. What's worst is we're going to see innovation by those who wish to bypass these new operating conditions, new inventions, new protocols, new heuristics, new private relays, new ways to restore the old visibility. This will be a war of one-upmanship. It will be an incremental increase in complexity for the purpose of determining who gets to make the rules about traffic. Now, there were alternatives, and what we see around the world in all of human history is that a lot of actors begin with an attack, and then there's a fight for a while, and then after the fight has gone on, then negotiations occur, and you decide where will be the new border, what will be the new laws, who must make restitution to whom, that kind of thing. But the reason that you start with a fight instead of just asking for negotiations is because you want the negotiation process to be in your favor. You want to first improve the operating conditions, improve the status quo, so that when you negotiate, you're negotiating from that new position. And that's what's happened here. Eventually, we're going to have to negotiate with our nation-state actors and with our firewall operators, and perhaps with our ISPs. It's difficult to know the shape of the conference table where negotiations will take place, but negotiation will eventually take place. I believe it will take the form of a protocol by which devices can learn the policy. And if they're incapable of following that policy for whatever technical reason or monetary reason, then they can simply fail, or they can take a risk and try to use the network against the local policy. So I think we're going to see a policy protocol that will make it possible for an edge network operator to negotiate with their supply chain and negotiate, I guess, with botnet operators and intruders and everyone else. That's not where we started for the reasons I've given. It's going to take some years before the battle has been fought long enough and enough costs have been paid by all sides before we will begin to work on this protocol. I wish it were otherwise. So that's my talk. I want to note that if you are, like me, a fan of the original Star Trek television series from the 1960s, you might remember an episode of that TV series where a new computer is installed, which turns out to be intelligent, and it wants to sort of take control and make sure that it cannot be interfered with. And so what's shown here is a still frame where the computer has established a direct power conduit to the ship's engines. It is an endpoint, and it has demands. And our endpoints on our networks are also about to tell us their demands. They're about to directly connect to the power core of the internet itself and dare us to unplug them. It's a bad state of affairs, and it's going to be expensive. And I thank you for listening to my story, and I hope we have questions.
Thank you. Thank you. Iberiu.
Thank you for the presentation. I would like to ask you, what can be done with all the attacks, security attacks that come from Amazon Web Services and other type of services of the sorts?
Well, first, let me make clear that although I work for AWS, Amazon Web Services, I am on the security team there. I am not here today representing Amazon in any form. I am here as an invited expert on this topic. And I've been speaking on this topic for some years now, longer than I've been at Amazon. So I have some knowledge of how cloud operators prevent bad traffic from leaving their network. It's really no different from what I've said. All the cloud operator is going to have access to is the traffic flows. And most cloud operators are known to encrypt customer traffic. In other words, cloud users, companies who have put resources into the cloud. The cloud operator is, generally speaking, encrypting everything. And so there's no way to do payload inspection. All you can really do is look at the quality of the flow of traffic. And so, it may be that a DDoS looks like a DDoS, and you can see it in NetFlow, for example. And there are other bad traffic types, which are similar. Inevitably, if a cloud is global and has 1 million or millions of customers, some of those customers are going to get breached. There will be malicious insiders inside the cloud, and they will do things that perhaps the cloud has a way to automatically detect and thus filter out. But maybe it's an evasive attack. It's designed to prevent detection, in which case the cloud operator would receive a complaint from some outsider. Hey, how come you're DDoSing me, or how come you're spamming me, or what have you? And in that case, every cloud will have a team. It's usually called the trust and safety team, whose job is to receive those complaints from outsiders and to investigate them internally to find out what is the cause, and if it isn't a customer infected with a botnet, to then work with that customer to improve the trust and safety of the whole network and of that cloud. So I hope you understand why I have to speak in generalities. I will not represent Amazon in this event.
Do we have news from Ed Snowden that you mentioned?
I have not followed Mr. Snowden's endeavors very much, but to the extent that it becomes news, I can tell you that he has spoken on the plenary stage, giving a keynote of sorts to the Internet Engineering Task Force. Now, of course, he could not do this in person because he is he's being sought. There's an arrest warrant for him, and their extradition has been requested. So if he leaves the country where he resides, which is Russia, he would be arrested and brought to the United States for trial. So he did not travel to IETF, but he had a kind of a robot. It looks like a little bit like a rideable two-wheeled robot, but instead of a person, it has a video screen. And so he attended IETF virtually in that way, and he spoke to the assembled audience in that way. But that's the only thing I have seen or heard in recent years. So as far as I know, he lives in Moscow. Presumably he's found work, and presumably is making a life for himself there.
My name is Otto. First of all, it's an honor, sir, to meet you even by conference. And thank you, Mr. Rotaro, for inviting me here. So I would appeal to your expertise in security. And maybe if you look ahead and can point us, how do you see, because we have this trend of migrating everything to the cloud, like all businesses, family photos, and everything. Mobile phones accelerate this. Do you see this trend returning? Do you see from a security standpoint, or will there be a reverse of this, maybe going to the edge again? How do you see the future here?
It's necessary that my perspective be informed by my experiences. And about 1.5 years ago, I was invited to join the security team of a global cloud operator. And some of the way I will answer your question has been informed by that experience. The idea of a so-called home lab, where somebody gets together a bunch of Raspberry Pis or other cheap systems that are programmable, and they install Linux on them, and then they'll create their own postfix server, their own Nginx server, and they'll play with this stuff so that they can familiarize themselves with how it works, or maybe even begin to explore new features by deploying them locally to find out if they work. That's how the internet was originally made, and there are still a lot of people who work that way. So I myself have always operated my own name servers and my own mail servers and so forth. And so I have a tiny little island of capacity, and that's what my family depends on for my family's operations. I did the same at my last startup company, Farsight Security. We did use one of the public clouds, but we only used it for encrypted backups because everything else we wanted everything else to be native. The problem with this model is that it calls for a type of expertise that is no longer universal. In fact, it's not even common. And that expertise is the ability to rack up a bunch of one-use servers and install operating systems and services on them, connect the whole thing to the internet, and offer your services to the extent that maybe you're in the business of providing services over the internet. That won't work. It won't scale. What you need to be doing is to have that capability across different regions. It cannot be that, for example, your service is very fast for those in Romania, but very slow for those in Hong Kong, as an example, as a random example. You're going to need some way to act globally. And the expertise required to replicate your services across the world and to make them available to user populations that are far from you is dwindling. The number of people who know how to do it is not changing. We're not creating new ones. We have an existing population which is barely replacing itself with death and birth. And yet the need to behave this way is growing. So the cloud was inevitable in that sense. And for a company, let's say, who is in business to do something, they may not be in the business of running their own web server. They simply have to have a web server so that they can do their real business. And I don't know what the real business might be. But for them, it would be very expensive to maintain a global infrastructure that they owned and then operate it and monitor it for capacity, for attacks, for the need to patch, the need to upgrade, the need to add capacity. These are things which would be costs for most companies, and there would be no corresponding benefit from that cost. In other words, becoming really good at that is not going to make you more profitable at the thing you're actually in business to do. And so it is inevitable that companies who understand their total cost of operations will eventually drift into or deliberately migrate into one or more public cloud. Now, some will pull back if it turns out that they actually have other reasons why they must be an expert at doing what the cloud itself will do. Then, yeah, you'll see them buying servers and putting them in data centers and internet exchange centers around the world and staffing for that. But that will never again be common because the need to do that is so rare. And so this becomes a build versus buy decision. And for most companies, it is much cheaper to buy it than to build it and to then own all of the problems. Now, since we're speaking mostly about security, I want to point out that every online service has a dependency on a stack. You know, the service has to be somewhere, so there's dirt. And then there has to be inside of a building, so there's steel and concrete. That building has to have power and connectivity, and so there's electric cabling and fiber optic cabling. That power and that networking has to be diverse. So there's probably more than one source, and it has to be resilient. So there's probably a backup generator, maybe also an uninterrupted power supply. There's a router that connects the network to more than one upstream provider. There has to be servers, and those also must be resilient. So there has to be more than one server. So there's probably also got to be a load balancer. The server has to have an operating system, and then the services running there are software packages themselves. All of that has to be monitored to find out if there's a critical zero-day vulnerability, and we have to patch it right now, even though it's time to go home. So, you know, and on top of that is the application, which might also have maintenance requirements. And then the customer data has to be stored somewhere, and that needs to be resilient. So you've got RAID. You've probably got multiple RAIDs with some kind of replication protocol. All of that must be done. And my question for anyone who is wondering about the total cost of operations of building versus buying is, are you going to be fully responsible for every level of that tree or of that stack, everything from the customer's data all the way down to the dirt? Are you going to be an expert? Are you committing in perpetuity to understanding all of that and to monitoring it carefully and to replacing it when depreciation occurs and it wears out, expanding it when capacity is needed, patching it whenever it needs to be patched, accepting complaints from outsiders in case you get breached and somebody's DDoSing you or copying your data to the dark web? Are you going to commit to full understanding of every single part of the stack between your customers and the dirt under the data center? I think no. I think you're going to have to count on others to do some part of that. Most of us count on the data center and the power and the cooling and so forth to be provided by someone else. And we count on the network to be provided by somebody else. And we don't necessarily create our load balancer using open source software. We're probably using an appliance for that, as we do for our routers and switches. From there, you have to make a similar total cost of ownership decision where the total cost of ownership includes securing everything. And if you're not going to commit to securing everything from the host and the operating system and the services and the microservices and so forth, then you have to find someone who can commit to that. And you have to bring them on board as a partner in your venture. That is why the cloud grows. Sorry for such a long answer.
It was perfect. Thank you.
So if there will be in time more questions, how we can reach you? I will collect them and send to you, or how we do? Because the time here in the room is limited and we cannot afford staying. Yeah. What do you think? They will send them to me and then I'll send to you and so such connect with them?
I think that's fine. I would look forward to continuing this discussion with anyone in that room. I wish I were in that room so that we could talk
Definitely.
in the hallways.
Yeah.
So let me just tell everybody, I'm on social media as Paul Vixie, one long 9-letter word, my first name, my last name. And if you wish to converse with me, one way to do so would be to connect with me on LinkedIn. If you do so, please mention this conference so I'll remember how we met. If you want to reach out directly, I am paulvixie@gmail.com.
Okay, that's good way to talk with you. Excellent. So again, thank you. I'm happy that we could do in this way. It worked. It worked better than 2 years ago when we met at that conference here in Bucharest. I mean, it will be more efficient for all the people in this room. So thank you again, and we were very happy to have you here in this conference. Bye.
I was honored by the invitation. I hope to be there in person maybe next year. Thank you all.
Okay, bye.